Welcome back, everybody. Thanks for watching. So here we want to establish the cosine of the difference of angles formula. So how do we prove that this is true? Let's start with the unit circle. So assume this is the unit circle. And let's pick a couple points on the unit circle. Maybe here and here. And let's connect to the origin. So if I connect to the origin, let's see what we have here. So here's my origin. And let's see here. So I've got this. And then also this. So I'm just extending these radii out, which since that's the unit circle, they'll have length 1. And then I also want to connect here. So I want to connect these 2 points here as well. And so this point right here, let's call this A. This point right here, let's call this B. And this little side here, let's call this little c. Since this is the unit circle, this is length 1, and this is length 1 because they're both radii. And let's form a triangle right here. Okay, so let's talk about this angle right here. Let's call this little angle here beta. And let's call this entire angle here, let's call that alpha. So this, let's see here, this right here is alpha, this angle, and this right here is beta. Well, since these are points on the unit circle, so we know that B is going to be the cosine of beta, comma, the sine of beta. And then for A, that should be the cosine of alpha, comma, the sine of alpha. Okay, so there's 2 computations that I want to do. The first thing that I want to do is use the distance formula to measure C. And by the way, this is our proof. So using the distance formula, so let's see what we have here for C. So we should have the difference in the x-coordinates. So cosine alpha minus cosine beta, quantity squared, plus the difference in the y-coordinates. So that's going to be the sine of alpha minus the sine of beta, quantity squared. All right, so let's work this out. All right, so we need to square a binomial here, so that should be cosine squared of alpha minus 2 cosine of alpha, cosine of beta, plus cosine squared of beta. And then also we want to square this out. So that's going to give us, looks like sine squared of alpha minus 2 sine of alpha, sine of beta, plus sine squared of beta. Okay, so this seems pretty good so far. Let's look out for Pythagorean identities. So here and here, we know that sum's going to be 1. Cosine squared of alpha plus sine squared of alpha is 1. And then here, that pair will also give us 1. So that's going to be 1 plus 1. So I can replace those 4 terms with 2. Okay, so let's see what we have here. So that means that C is equal to, let's see what we have here. We have 2 minus, let's see, 2 cosine of alpha, cosine of beta, minus 2 sine of alpha, sine of beta. And now let's go ahead and square both sides. So squaring both sides yields the following. So we've got that c squared is equal to 2 minus 2 cosine alpha, cosine beta, minus 2 sine alpha, sine beta. So we want to hold on to this quantity. Let's maybe call this star. So that is one way to measure the length of c. The other way we can measure c is to use the law of cosines. So that'll give us a different way to measure c, and then we'll equate the two. Okay, so let's see what the law of cosines gives us. So I'm thinking about just separating this triangle here. So the first was by the distance formula. The second way to describe c is by the law of cosines. And so c squared is equal to this side squared plus this side squared minus 2 times 1 times 1 times the cosine of the angle between. But if I'm looking at this triangle right here, so what would be the name of this angle right here? Well, it would be alpha minus beta, right? Because if I want just this angle here, again, that would be the entire length alpha minus beta. So alpha minus beta is exactly this angle, which stops here. Okay, let's clean that up just a little bit. So that gives me that c squared is equal to 2 minus 2 cosine of alpha minus beta. So that seems pretty nice so far. What we can do now is equate this result for c squared with this result for c squared. So let's call this double star. So I'm going to say equating star, which was this, and double star. Let me tidy this up just a little bit here. We've got unruly math. There we go. So equating star and double star yields the following. Okay, so here we've got 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. And that's equal to this, right? They're both equal to c squared, so they're equal to each other. So that's 2 minus 2 cosine alpha minus beta. So we can subtract 2 from both sides. So we've got minus 2. In fact, we can factor out a minus 2 here. That's going to give me cosine alpha cosine beta plus, when I factor out that minus 2, sine alpha sine beta. That's equal to minus 2 cosine alpha minus beta, and dividing both sides by 2 establishes our result. All right, so the cosine of the difference of angles formula is established. And it turns out if we're really careful here, we can establish the cosine of the sum of angles formula using this and maybe properties of odd and even functions. Let's try it out. So, little sneak attack here, a little buy one, get one free. Let's take this formula and let's say we have the following. So we'll call this bonus math. Okay, so let's take this. So cosine of alpha minus, let's say minus beta, because that will give us cosine of alpha plus beta. So just take the formula that we established, and everywhere you see a beta, plug in a minus beta. So cosine alpha, cosine minus beta, plus sine of alpha, sine of minus beta. But that gives us that the cosine of alpha plus beta is equal to, well, remember cosine is an even function. It has y-axis symmetry. So maybe we'll put that as a little bit of a recall. So for all theta, cosine of minus theta equals cosine of theta. And then also recall for all theta. Well, with sine, remember sine is an odd function. It has origin symmetry. So that's equal to minus sine of theta. So using that right here yields the following. So cosine of minus beta is exactly the same as cosine of beta. Again, by symmetry, because cosine is an even function with y-axis symmetry. Now again, sine is an odd function with origin symmetry, so this is equal to the minus sine of beta. And so there's your buy one, get one free. Well, I've got a question for you. Let's do one more bonus math. So what's the cosine of 2 alpha? So if I want the cosine of a double angle, I can actually use this formula to establish that. So think about this. Cosine of 2 alpha, that's the same thing as cosine of alpha plus alpha. And so that means that everywhere I see a beta here, I should just plug in an alpha. So using this formula here, with beta equal to alpha, I've got cosine alpha minus sine of alpha, sine of alpha. But that's exactly the cosine of 2 alpha, which is cosine squared of alpha minus sine squared of alpha.